Also, did you know that in Galileo's time, his first prediction of the sun of the the distance of the sun, it was actually 3 million miles away for a long time.
Flirts are so bloody annoying, aren't they? No, Galileo did not make that calculation at all. Aristarchus made a calculation of approximately 5 million miles. But this was long, long before Galileo. As you could probably tell by the name, he was an ancient Greek mathematician. I mean, I'm kind of shocked that this is actually a surprise to you. I mean, you should know that things simply just get better over time. Everything from athletes to society, and yes, science and mathematicians. Okay, so there's a very specific question that you want answered, and I can answer it for you.
Okay, so it we used to have a number that was maybe 3 million, and I don't know if I really don't
Why
think that
was he
that's
so wrong though?
Okay, so I'm just going to let a video play now, and it's going to explain exactly how Aristarchus got his measurement to the sun, and exactly why he was wrong. So how is it we've known for a long while the distances to the moon and the sun? Well, the first person to calculate and discover that the sun was much further away than the moon was Aristarchus. And he was an ancient Greek mathematician and astronomer. And he used trigonometry to figure all this out. He used a moon, earth, sun angle when the moon was half full. Now, in order to get this calculation, he would need to know this distance. And he did. But this was no guesswork. And with some help from another brilliant mathematician of the time, Eratosthenes, he knew the approximate circumference of the Earth. And this enabled him to just rearrange the formula to get the radius of the Earth. And since he knew the radius, he obviously knew the diameter. And knowing the diameter of Earth was key, because experimentations and observations led them to understand that an object passing in front of the sun would produce a conical shadow 108 times that of its diameter. So at this point, he knows that the moon is no further than 864,000 miles away. And he knew this because the moon, without doubt, passed through Earth's shadow, and Earth's shadow reaches no further than 864,000 miles. And from careful observation, they concluded that the diameter of Earth's shadow was 2.5 times that of the moon's diameter. But there was one more key observation that he had to take into consideration, and this came during a solar eclipse, and the fact that the moon is the same apparent size as the sun in the sky. And what this meant was that he knew angle ECD was the same as EAF. And we've already determined that length FE is 2.5 times the length of ED. And I'm sure some of you have already clocked on that length AE is going to be also 2.5 times the length of EC. From there, we can conclude that the entire length AC is 3.5 times that of EC. So now we've got all the information we need to make the final calculation. We know the distance of Earth's shadow. This is 108 times Earth's diameter at 8,000 miles, which works out to be 864,000 miles. And we've now worked out that the moon is 3.5 times shorter than that distance. So all we do now is divide 864,000 by 3.5. And you will see that Aristarchus and his calculations for the distance to the moon were bang on the money. And once they've figured out the distance between the Earth and the moon, it's fairly simple to find out the distance between the Earth and the sun. So now we can go back to the model that we had at the beginning, where we, or Aristarchus, can solve for the rest of the triangle, or more specifically opposite, to find the distance to the sun. Aristarchus measured the moon-Earth-sun angle at 87 degrees. At this point, he also had the distance to the adjacent moon. Now we actually have everything we need to solve. We're going to take the tangent of 87 equals the opposite over adjacent. We know the adjacent to be 246,857,000 miles. So we've got all the figures we need, so we can get rid of this now. I'm sure many of you are going to know, maybe not the flurflings, but many of you are going to know that the tangent of 87 equals opposite over adjacent. And we've just worked out the adjacent, that's the distance to the moon, and that's cool. But what we want to find out is what opposite equals. So from now on, we're going to call opposite x. And now it's just basic algebra. So x is going to equal the tangent of 87 multiplied by the distance to the moon. So x equals, and Aristarchus concluded that the distance to the moon was approximately 4,710,000 miles. Now, I'm sure some of you know that that is only about 5% of the true figure. But we're going to cut old Starkey some slack. Because one, he was the first person to ever do this, and was still correct in his conclusion that the sun was much farther away than the moon. And two, he would have needed much better equipment to get the exact angular measurement. For instance, he concluded that the angle was 87 degrees. But the correct angular measurement is about 89.847 degrees. And so 87 isn't far off the mark. But small errors account for big mistakes in trigonometry. For instance, had he just measured that angle at 89 degrees, he would have been short of the mark by approximately 79 million miles. And that's it for this video. Thanks so much to all of my support. You're all brilliant. In my next video, if you guys like this one, I'm going to go into Eratosthenes' measurements of the same. He got a much more accurate measurement. And that is it. I'm going to start shouting people out again when I do my Sumerian videos, which is coming back very soon.